wanted to give you guys a nice here presentation about redox reactions because the lab that we're going to be doing in the Chem 151 with the decavanidates requires the understanding of redox reactions. But this can also be applicable to your lecture or anytime you need to balance some redox equations. The reason that I have the lion image on this first screen is it reminds me of the easy way to remember this, which is Leo the lion says grr, and that stands for you lose electrons, you're oxidized, and if you gain electrons, you're reduced, right? So that's Leo and grr. Okay, so let's continue here. Move down. Okay, when you see this reaction, sodium oxalate with permanganate, and it goes to carbon dioxide, then you've got the anions and cations there with sodium and manganese. Is it balanced? Obviously we know it isn't. You can see just quickly you have two carbons on this side. On the left you only have one carbon on the right. So you have to figure out what to do. And here's what you can do. Step one is split it into two half reactions. Okay, and it's actually a 5-step process. So we're going to focus on one step at a time. So with step one, you split it into two separate reactions. Okay, so you see your two species, which is the sodium oxalate and the permanganate, and so you can identify those components. And you then split them into two reactions. Here's your two half reactions. So you can see that the purple, the color coordination comes together, and that's obviously just a breaking apart. And then in this case, you just see the manganese going from here to here. Now, what you do, step two, is you balance each half reaction, except for the hydrogen and the oxygen. Don't worry about those yet. Let's just focus on carbon and the sodium, etc. Right? So in this case, for this first half reaction, you need to balance the carbon, so you add the coefficient 2 out front to get the carbons balanced, and then you add the 2 in front of the sodium to balance the sodium. When you take a look at the second half reaction, you see that in this case it's balanced. So you're done for that one. Now let's go to step 3. So now we've done the elements. Now let's focus on oxygen. So you balance oxygen using water. And then once you're done with that, then you can use the hydronium ion to balance the hydrogen. When you take a look at the first half reaction and you take a look at oxygen, you see that you have 4 oxygens on the left and you have 4 oxygens on the right. So oxygen is balanced. And for the second half reaction, you have 4 oxygens on the left. So you add 4 waters to get your 4 oxygens. Now, what you need to do is balance hydrogen. Since we know that we didn't do anything here, we're just going to focus on the second half reaction. Because we added 4 waters to balance the oxygen, we now have 8 hydrogens on this side, so we add 8 hydrogens on the left. So now the oxygen and the hydrogen are balanced. Now, step 4, you need to balance the charge. And you use the electrons to balance that charge. So if you take a look at the first half reaction, you can see it's a neutral species on the left, so you've just put a 0. And when you take a look over here on the right, you have a 0 charge here. Carbon dioxide is a neutral molecule, and then you have the sodium plus, and you have 2 of those, so you have a plus 2. So in this case, we're going to have to balance the left and the right, and we can do that with the electrons. Now, if you take a look at the lower electron, you can figure, or lower reaction, you can take a look yourself, and you can see that you have 8 plus and then 1 minus for plus 7, and you have 2 plus, and this is neutral, so it's just a plus 2. So in this bottom part, you can see how we use 2 electrons to balance. So you get plus 2 minus 2 for 0. That balances. And in this case, you have 5 electrons, and you do plus 7. So that equals plus 2. And then these sides are balanced. Now, step 5. What you want to do is make the electron number in the 2 half reactions match. And in this case, since we had 2 electrons in the first half reaction and we had 5 electrons in the second half reaction, you just multiply. Let me close that down. You just multiply by, the factors here. So 5, and you multiply across this whole half reaction. And then here you multiply this whole half reaction by 2. And so you can see there's 5 10, 10, 10. In this case, you've got 10 electrons, and 8 times 2 is 16, et cetera, 2, 2, and 8. Now, the last step is to add these two half reactions back together. And you also want to cancel identical species. So we're gonna play this game when we're looking at Hess's law. If you down the road with thermodynamics, it's sort of the same thing. You basically want to balance this thing, and you cancel identical species that are on either side of the arrow. And you can see, obviously, we set it up so that the electrons cancel each other. I mean, that's why we multiplied through so that they were equivalent. And those cancel. And then you look for other species that may cancel, and then you just write your final equation. And then in step 7, you can double check to make sure that it's balanced. And it's just sort of a fun thing to do. You've got 10 carbons here, and you go over here, and you got 2 carbons in this molecule, and there's 5 of them, so that's 10. So I start to play that type of game. I got 10 sodiums here, and I just go over here, and I got 10 sodiums. So that, my friends, is how you do redox equations. And you can play this as much as you want and really enjoy it. Because, let's see, if we take a look at the end of this slide presentation, these are the 3 equations that you will need to balance for this lab. And you will follow the same principles and the same steps that I just outlined in this presentation. Have at it, have fun, become masters of redox equations, okay? Have fun. Thanks. Bye.